Okay, let us continue. And now what we'll see is we'll look at the applications of an array. Two important applications of an arrays are, one is called as sorting and another one is called as searching. Even though from your syllabus point of view, we'll just have a look at two sorting techniques. One is called as bubble sort and second one is called as selection sort. And from the searching point of view, we'll have a look at linear search and binary search. When you go to the higher semester, you have a subject called as data structures using C, where you will be exposed to varieties of sorting algorithms like merge sort, quick sort, heap sort, bucket sort, shell sort, address calculation sort, and a couple of more. Right. So as of now, let us focus on what is called as bubble sort and how does bubble sort and selection sort works. Now, before that, let us try to understand what exactly is sorting. Sorting data, that is actually placing the data into a particular order such as ascending or descending, is considered to be one of the most important computing applications. For example, a bank sorts all checks by account number so that it can prepare individual bank statements at the end of each month. Similarly, I can give you one more example. Telephone companies sort their list of accounts by last name and within that by first name, so to make it easy to find the phone numbers. In fact, if you ask me, virtually every organization must sort some or the other type of data, and in many cases massive amounts of it. Sorting data is an intriguing problem which has attracted some of the most intense research efforts in the field of computer science. Right? So this is basic meaning of why you require sorting and where it is used. Now let us have a look at the first sorting algorithm called as bubble sort. Right? Now this is the most widely known among beginning students of programming, that is called as bubble sort. That means that bubble sort actually happens to be the first sorting algorithm which is exposed when somebody is trying to do programming. The reason behind is it's very easy to understand and it's very easy to code also. Now let us see the procedure. How does the bubble sort algorithm works? So you have the procedure in front of you, right? I'll just give you a couple of seconds time, just go through it and I'll explain this procedure with an example. Now, let us try to understand that procedure with an example. Let us say I have an array with 7 numbers. With 8 numbers. And the numbers are given to you in front of the screen. Let us say the array name is array name is A. So it starts from subscript 0 to 7. A of 0 is 25 and up to A of 7, which is 33. Now, let us see. We implement bubble sort algorithm on this array to ensure at the end of the day the elements are sorted in ascending order. Now what happens is, during the first pass the following comparisons are made. Now what do you mean by first pass? One of the common questions that is asked is, at the end of each pass what happens in different sorting algorithms. Say for example, I can pose an interview question like this. At the end of first pass, what happens in bubble sort algorithm? Similarly, at the end of first pass, what happens in case of quick sort algorithm? So as a programmer, you should know what exactly happens at the end of each pass of various sorting algorithms. Right? Now, before we draw conclusion as to what happens at the end of the first pass of bubble sort algorithm, let us see what are the steps involved in terms of comparisons and what is the outcome of those comparisons in the first pass itself. Now the first step of the first pass in bubble sort algorithm tells that you compare A of 0 with A of 1. That is, you compare the first element with the second element of your original unsorted array. I repeat, you compare the first element with the second element of the original unsorted array. So in this case, I am trying to compare 25 with 57 and 25 is less than 57. And hence what it says, if the first element is less than the second element, you don't do interchange, meaning you don't swap the elements of the array. So 25 will be in its place and 57 also will be in its place. Then what you do is you compare the second element with the third. That is, you compare a of 1 with a of 2. 57 you compare with 48. 57 is greater than 48 and hence you swap it. You interchange it. So when you interchange 57 with 48, you will get the elements like this. You have 25, 48, 57 and so on. You see the 57 is now shifted towards right by 1 and 48 takes place of 57. Then what you do is, once this 57 is swapped with 48, now you compare this 57 with 37. Actually, you are trying to compare a of 2 with a of 3. 57 with 37. Since 57 is greater than 37, you are going to swap it and then you get elements like this. Then further, you compare 57 with 12. It is greater, so you swap. Then you compare 57 with 92. Since 57 is not greater than 92, swapping will not take place in this case, right? And hence the elements of an array will be like this only. But comparison will not stop because you have not reached the end of the array. And hence what you do is, now you compare 92 with 86. 92 is greater than 86, so you interchange. See the position of 92, where is it, right? So if you look from the beginning, 57 has changed its position and then now 92 also has changed its position. We have still not reached the end of the array. So in the next step, what you do is you compare 92 with 33. And this is what you have. Now you compare 92 with 33, and since 92 is greater than 33, you interchange. Now look at the position of the element 92, which is at the end. We have come to the end of the array. Now what happens is, since no more comparison will take place, we draw conclusion that we have come to the end of the first pass. And at the end of the first pass of the bubble sort algorithm of this particular example, we have the elements like this. Now what is the conclusion drawn? At the end of the first pass of the bubble sort algorithm, the largest element of the original unsorted array is in its proper position. You will see here 92 is in its proper position. Now the reason why this is called as bubble sort algorithm is, if you look at your original array, in your original array 92 was there in a particular place. From there it jumped to next place, that is it bubbled to a particular place, then again it bubbled. So the largest element from its original position keeps on bubbling in such a way that it comes and sits in its final position. Now this is the prime reason why it is called as bubble sort algorithm. So I repeat, at the end of the first pass, the largest element of the original array will be always in its proper position. And given n number of elements, bubble sort algorithm will take n-1 passes, that is n-1 steps. Since this particular array has got 8 elements, the total number of passes required for this particular problem to get the elements in the ascending order is totally 7. So this is how basically your bubble sort algorithm works. Now this is the complete set of iterations what you have it, right? Just have a look at it. Now if you closely observe, you have iteration number 5, 6 and 7, the elements are same, right? This happens because don't think that only when you look at this on the paper, you feel that elements is already sorted, but as such, it is not sorted for the system or for the computer. It will still do its iteration. And that is the prime reason, right? You have totally 7 iterations and the number of elements are 8. Bubble sort takes n-1 steps, n-1 iterations to get the elements in ascending order. This is the formal algorithm of bubble sort. right? Just have a look at it. That's the advantage of BubbleSort. As I told you earlier at the beginning, it is simple to understand and easy to implement, but at the same time, the greatest drawback is it is considered to be the most inefficient sorting technique, right? Say for example, BubbleSort is good if the number of elements to sort is very less, maybe 10, 15, 20, 30, 40, something like that. But in real life, you'll end up sorting too many elements, right? If you are trying to talk about sorting around 10,000 elements, then BubbleSort is the most inefficient sorting technique, right? And at the same time, according to me, if any programmer uses BubbleSort, right, to sort 10,000 elements, then not only BubbleSort is considered to be the inefficient sorting technique, I feel the programmer himself is also inefficient programmer. And apart from that, the disadvantage of BubbleSort is it is the slowest sorting technique. Now let us move to the next sorting technique, what is called as selection sort. Now selection sort is a simple sorting algorithm which is in place comparison based algorithm where the list is divided into two parts, the sorted part at the left end and unsorted part at the right end. Now what we do is initially the sorted part is empty and the unsorted part is the entire list. Let us have a look at this selection sort with an example. So I have an array whose name is A, and I have 5 elements all the way from A of 0 to A of 4. So the elements of the array you can see on the screen. They are 20, 12, 10, 15 and 2. Now during the first pass, the following comparisons are made. A of 0 with A of 1. That is 20 is compared with 12. We find 20 greater than 12, so we interchange and we get the elements as 12, 20, 10, 5 and 2, this one. Then what we do is we again compare the first element. That is, now it is actually newly obtained element. Initially A of 0 was 20. After interchange, A of 0 became 12. So we now compare this 12 with 10. That is, we compare A of 0 with A of 2. And then we find that 12 is greater than 10, so we interchange 10 and 12. Now see the beauty, 10 will come to the first place and 12 will go to the third place. So I have 10, 20, 12, 15 and 2. In the next step, I am going to compare the newly obtained A of 0, that is 10, with 15. And since 10 is less than 15, I will not do any interchange. Then I will compare the same 10 with the last element, that is A of 0 with A of 4, and I find that 10 is greater than 2, so I interchange, and now I have the element as 2, 20, 12, 15, 10. Now this is the end of the first pass. Now when you carefully observe, at the end of the first pass of the selection sort algorithm, the lowest element of the original unsorted array is in its final position. You see, 2 is in its final position. In the sense, 2 is actually in the first position, right? And at the beginning of the selection sort, I have said that the sorted part is empty and the unsorted part is the entire list, right? That means what? The sorted part is at the left side and the unsorted part is on the right side. So what is sorted part here? The element 2. And the unsorted part is on the right side. That means as of now, all the elements which comes towards the right side of 2, they are called as unsorted part. They are the elements of the unsorted part. 20, 12, 15 and 10. You see, they are not sorted. 20, 12, 15 and 10. That is why it is called as unsorted. Now, I will go with the second pass. Now, when I go with the second pass of the selection sort algorithm, I am not going to do anything with the sorted element, that is 2. And hence, my entire focus will be now with A of 1 onwards. That is from element 20 onwards, right? So the explanation is given on the screen. I think it is self-explanatory. So I compare 20 with 12, interchange. then I compare 12 with 15, no change. I compare 12 with 10 and I change, and hence what happens at the end of the second pass, the second smallest element is in its correct position. So 2 and 10 is on the left side, which is sorted, and 20, 15, 12, which is on the right side, which is, we call it as unsorted part. So similarly, when we proceed like that, these are the complete set of iterations, and finally at the end of fourth step or the fourth iteration, we get the entire elements in ascending order, right? So one of the things that is common in case of bubble sort and selection sort is both these sorting techniques takes n minus 1 iterations to sort the elements in the ascending order. In this particular video, we will see the program for bubble sort and trace this particular program. Now I have made use of certain variables n, I, j, temp. We will see the significance of these variables as and when we proceed. And I've also made use of an array called as a, whose dimension is 20. And then the total number of elements that you want to sort is stored in a variable called as n. And with the help of this for loop, I am going to enter the elements of an array which will be stored in an array A. And then I am making use of these two for loops and if statement, which is totally responsible for doing my sorting business. Now I have the outer for loop whose control variable is j, and I have my inner for loop whose control variable is I. And once the control comes out of the outer for loop, with the help of this for loop and printf, I am going to print the elements in the sorted fashion, or probably the elements in the ascending manner. Now let us trace this particular program. So what I'm going to do initially is I'm going to write all these variables here in my tracing part. So you see I have all the 4 variables here, and then let us say my value of n is 5. That means what? I'm trying to trace this particular program for 5 elements, right? And as I told you earlier, with the help of this for loop, I'm going to input all the 5 elements which will be stored in my array. So initially value of I is 0, I less than n, where n is 5, so 0 less than 5, true, and then it will go inside, and whatever I enter will be stored in the variable or the array called as a of 0. So let us say I have a of 0 as 9. Then I plus plus becomes 1, 1 less than 5 condition is true, so the scanf will be executed, and now whatever I am going to enter will be stored in variable a of I. So let us say a of I is 17. Similarly, I land up writing the elements, all the elements of an array. So let us say I have 11, I have 6, I have 3. So this is how I land up having all the elements of an array. Now let us proceed further. I have this particular for loop, right, which is the outer for loop, whose control variable is j. Now this for loop ranges from j is equal to 1 to j less than n. What's the value of n? That is 5, right? So less than 5 is nothing but 4, right? So I will have my j all the way from running from 1 to 4. So initially my value of j will be 1, right? So 1 less than 4 condition is true, so the control will come inside. I have my inner for loop, which is nothing but I is equal to 0, I less than n minus j, right? So my initial value of I will be 0 and it will go up to what? My n is 5, right? And my j is 1, right? So 5 minus 1 becomes 4, and less than 4 is 3, and hence my value of I will be all the way from 0 to 3, right? Now initially my value of I will be 0, okay? So watch out carefully, my both the for loops, right? The outer for loop initial value is 1 and my inner for loop the initial value is 0. Now I go inside this statement and I'm going to check if a of I is greater than a of I plus 1. I is 0, so a of 0 is 9 and I plus 1 is 1, so a of 1 is 17. 9 greater than 17, condition is false. Okay, and then this I plus plus will increment the value of I and makes it as 1. And then again it comes to this particular statement. Now I'm going to check whether a of 1 is greater than a of 2. So my a of 1 is 11, 17, my a of 2 is 11. Yes, 17 is greater than 11. Since the if condition is true, my control will go inside the if, and these three statements will be executed. Temp is equal to a of I. I is 1, a of 1 is 17, so my temp becomes 17. Then a of I is equal to a of I plus 1. That means what? A of 1 is equal to a of 2. My a of 2 is 11, so my a of 1 now becomes 11. And then here a of I plus 1 equal to temp. That is a of 2 equal to temp. My temp is 17, so my a of 2 becomes 17. Correct? And then I plus plus will increment the value of I as 2, and then I will check with this if a of 2 is greater than a of 3. So a of 2 is 17, it is greater than 6. So again my temp will come into picture, right? Now what will happen is my temp will be a of 2. So my temp will be again 17, then a of 2 is equal to a of 3. So what is my a of 3? Is 6. So my a of 2 becomes 6, and then with the help of this statement my a of 2 becomes, sorry, my a of 3 becomes 10. So this will be 17, right? And then my I plus plus will make value of I as 3, and then if a of 3 greater than a of this one, a of 3 greater than a of 4, yes, 17 is greater than 3. Again I am going to make use of this temp variable, and then I will swap these two, a of 3, a of 4, and finally what happens, my a of 3 will be 3, my a of 4 will be 17. And then I plus plus will make the value of I as 4. Watch out carefully. 4 less than n minus j. The condition is false, and the control comes out of this for loop and then goes to the outer for loop increment counter and makes this value of j as now 2. Right? It makes the value of j as 2. Right? Now, once this happens, the conclusion drawn is we have completed the first pass of the bubble sort algorithm. And what we have seen is at the end of the first pass of the bubble sort algorithm, the largest element of the original unsorted array is in its final position. Let us have a look at it. Right? My a of 0 is 9, a of 1 is 11, a of 2 is 6, a of 3 is 3, and a of 4 is 17. Watch out carefully. It is 9, 11, 6, 3, 17. Right? Now 17 is in its final position. Now this is what happens at the end of the every pass of the bubble sort algorithm. Right? Now once j becomes 2, right, when the control goes to the for loop for the next time, I will be reset to 0. So now what happens is I will remove all this. Now I will be 0 and less than n minus j. Now watch out, my n is still 5, but j has become 2. My j has become 2, and hence my I will be, right, now 5 minus 2 is 3. So this will be less than 3. So my I will be 0 to 2. Watch out carefully. And then my initial value of I will be 0. And then I am going to check if a of 0 is greater than a of 1. So 9 greater than 11, condition is false. Then my I becomes 1. Now I am going to check 11 greater than 6. Condition is true, and hence the control will go inside. Temp will be a of I. My I is 1, so temp will be a of 1. So my temp becomes 11, right? And then my a of I is equal to a of I plus 1. That is a of 1 will be equal to a of 2. My a of 2 is 6. So my a of 1 becomes 6. And then my a of 2 becomes temp, which is 11. And then I becomes 2, a of 2 greater than a of 3, that is 11 greater than 3, right? Again, with the help of this temp, I will swap this and my a of 2 becomes 3 and my a of 3 becomes 11, right? And then you look at this particular value of I, it is already for it is already executed for 0, 1 and 2, and hence the control of the for loop, sorry, the increment counter will become now 3. The condition is failed, and then it will go to the outer for loop where j becomes now 3, right? That means what? I have completed the second pass. Now watch out the elements at the end of the second pass. It is 9, 6, 3, 11, and of course I have 17 already in its correct position. So at the end of the second pass, my second largest element of the original array, that is 11, is already in its correct position, right? So again the j++ will get incremented, the for loop gets reset, and like this it keeps on happening till the control comes out of the outer for loop. That means what? Once this particular condition is failed, the control comes out of the for loop. And once it comes out of the for loop, I have to print the elements in the sorted fashion. And hence, at the end of the day, I'll get my sorted fashion elements as 3, 6, 9, 11, and 17. So this is what I get the output after implementing this particular program for 5 elements with the appropriate input.